Good morning, ladies and gentlemen. We're going to start our next unit, linear relationships. So today's going to be a nice, easy day where we just go over some of the groundwork. We're going to just go over some graphing with you. This unit is going to involve a lot of graphing. And so we need to make sure that we're all on the same page and we have the skills necessary to graph. So just starting to go over this slide, when two quantities are related in some way, they form a relationship. So in math, this is a big thing, is we want to look for relationships between two sets of data. So possible relationships that we might look for. Is there a relationship between, say, temperature and ice cream sales at the beach? Is there a relationship between your age and your hair color? Is there a relationship between how much time you spend studying and your math marks? So sometimes we find that there is a relationship, sometimes we find that there isn't. So between age and hair color, I don't know, maybe there's a relationship, but if you look at the average 5-year-old, they could have blonde hair, black hair, brown hair, red hair. I don't know if age necessarily, if there is a relationship. I know we can argue that when you get older, your hair might go gray. And so maybe there is, maybe there isn't. Lots of different times though. Is there a relationship between your weight and the color of pants you wear? Probably not. So sometimes there is no relationship, sometimes there is. Sometimes relationships follow a straight line when we graph them. So if I was to graph a job I have, and that's mowing lawns. So I mow lawns and I charge $20 per lawn. If I mow 0 lawns, I make $0. 1 lawn, I make $20. 2 lawns, I make $40. 3 lawns, $60. And when we graph this, we get a line. This is a linear relationship. This is going to be our focus in grade 9, linear relationships. In grade 10, you're going to focus on exponential or quadratic relationships. This is where, when you graph data, it forms this funky shape here called a parabola. In grade 11 and 12, and if you take physics, you'll actually get into relationships that form sine waves, that type of thing. But for grade 9, we're going to be focusing on linear relationships. But relationship is there a relationship between two pieces of data, temperature and ice cream sales, studying and marks? Sometimes yes, sometimes no, sometimes they form a straight line when we graph them. So another example here, the distance traveled by car depends on how long it's been traveling. So yeah, the distance you go is dependent on time. Variables, these are the two things that we're seeing. Do they have a relationship? So temperature is a variable, ice cream sales is a variable. Distance traveled is a variable, time traveled is a variable. So these are the values that change in a relationship. And we lump them into two different categories, dependent and independent variables. Dependent variables, like the name suggests, depends on the other variable. So the size of shoe I wear depends on how big my feet are. If my feet are a size 10, I will wear a size 10 shoe. My feet don't depend on my shoes. It's not like I go out and buy a size pair 10 or a pair of shoes that are size 10 and make my feet conform to them, or my foot size doesn't change because of that. My shoe size changes based on my feet growing. So shoes depend on feet, feet don't depend on shoes. So the dependent variable is the variable that depends on the other one. And therefore the independent variable is the one that stands on its own. Now, one way of representing a relationship is in a t-chart, or otherwise known as a table of values. We often call it a t-chart because you can see there's a t. And the independent variable we usually put on the, if this has been done correctly, we put it on the left side. So this is the dependent variable. Oops, my bad. Yeah, sorry, the independent. I said it right, but I wrote it wrong. So the independent is usually on the left side and the dependent on the right side. So how far I travel depends on how long I've been traveling. The left side is usually our x data, our x variable. And the right side, the y, is our dependent variable. So this t-table shows the distance traveled depending on the time. Another way of showing this relationship is with an equation. So for the equation above, I might define that as y is equal to 60x. My y value, my independent value, is equal to 60 times x. So you can see that if I take x and times it by 60, I get the y data. If I multiply this x variable by 60, I get the y. In each of these cases, when we multiply the independent variable, our x variable, by 60, we get y. So y is equal to 60 times x. We're going to be spending a lot of time in this unit making these equations. A third way to show a relationship is with a graph. So in the graph, the independent variable is always placed on the horizontal axis, horizontal like the horizon. So this is a horizontal axis. I'm sure in elementary school you were taught that it is the x-axis. If not, you now know. And the dependent variable is on the y-axis. And of course, if we go back to our t-table, we know that all the numbers on our on the x side here, they get plotted along the independent axis, the x-axis. And all our data from the y side of the t-table is going to get plotted over here. And we'll go over how to do that in this lesson. So here is the graph from the t-table that we just looked at. Time is our independent variable. Distance is our dependent variable. Distance depends on time. And if you recall, after 0 hours, we had gone 0 kilometers. 1 hour, we've gone 60 kilometers. 2 hours, 120, 3, 180. So that's taking the information from the t-table and putting it into graph form. And what are graphs useful for? Graphs are they're a picture. They're a snapshot. Looking at going back and looking at the t-table here, we got a bunch of data in the t-table, and if we want to clearly say, is there a relationship here? And I think we can say, yeah, a lot of us saw that 0, 60, 120, 180 are multiples of 60, and we saw some sort of pattern. Sometimes that pattern is not always as evident, but when you go to a picture of the data, a graph, very quickly we can say, oh yeah, there is a relationship, and in fact this is a linear relationship. It forms a straight line. So that's what a graph does. It allows us to see a relationship. All right, identifying the dependent variable. So what we have to ask ourselves here is, what depends on what? What depends on what is quite often a question I ask myself, and sometimes I ask myself a secondary question: what am I measuring, or recording, or researching? So the temperature and the amount of clothing people wear. The dependent variable here is clothing. So we have two variables. We have temperature and we have amount of clothing. And the amount of clothing depends on the temperature. Temperature doesn't depend on clothing. Mother Nature doesn't wake up in the morning and say, "Ooh, I noticed most people are wearing sweaters. I'm going to be cool today." Clothing depends on temperature. You and I wake up and we say it's going to be cool today. We're going to put on a sweater. So how we dress depends on the temperature. Now, what am I measuring? In this case, you might say, well, we're measuring temperature, Mr. Mitchell, but we're not really measuring temperature. We might be recording that, but that's not the focus of this study. The way that this question is worded, the focus here is clothing. We want to know if clothing is dependent on something. In B, a building needs 4 fire alarms per floor. So in this case, the dependent variable is the fire alarms. How many fire alarms we have to buy for this building depends on how many floors it has. The building doesn't say, oh, you have 28 fire alarms, so I'm going to be 7 floors tall. No, when you build a building, the architect says we want it to be 7 floors, and you must have 4 fire alarms. So the amount that we buy, 28, is dependent on the floor. So once again, we're not measuring how many floors there are. This data, or this question, the way it's worded, once again, is we're studying how many fire alarms are needed. So that's kind of what we're measuring. So René Descartes, 17th century mathematician, developed a system for graphing ordered pairs. Up until now, your elementary school teachers may have only been given you 1/4 of the graphing area. So quite often when we go to graph something, we do this and this, and we do our graph up in here, and we have our x-axis and our y-axis. That's only 1/4 of what we call the Cartesian plane. And we've normally only used this quarter because it involves positive numbers. So right here at the center, we call this the origin. And it's located at 0, 0. 0 on the x-axis, 0 on the y-axis. And as we move along the x-axis, we get 1, 2, 3, 4. And as we move up the y-axis, 1, 2, 3, 4. I'm just randomly throwing the numbers in. I realize that they don't necessarily match with the grid lines there. They're kind of small. And so historically in school, we've just used a lot of positive numbers for our graphs. So this is the only area that we have to move into. But of course, both these axes go into negative territory. So if I follow the y-axis down below the x-axis, we have -1, -2, -3, -4. So if we're graphing temperature or Mr. Mitchell's bank account, we might be graphing down here in the negative territory. Likewise on the x-axis, when we get left of the y-axis, we are into negative territory as well. And so more and more in high school, we're going to be doing some plotting and using these other other 3 quadrants. I don't think the flash doesn't work anymore. So we have the x-axis here. Once again, that's our independent variables. And our y-axis, which is our dependent. All right. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Don't memorize which ones they are. I'm never going to test you to say, well, what is this quadrant? Just know that there are quadrants. When we get into here, we have positive x values and positive y values. When we get to quadrant 2, we are still dealing with positive y values because we're above the x-axis, but these are negative x values here. In quadrant 3, we're still dealing with positive x values because we're to the right of the y-axis, but we're in negative y territory. And over here, negative x and negative y. but don't memorize that. I'm sure you're going to understand that as soon as we plot. And once again, this area right here, this little where the x and y axis intercept each other, we call that the origin. It's located at 0, 0. And if what I've just drawn here, what is called an ordered pair, doesn't make sense, we're going to get to that in a moment. All right, so it tells you how far you move along the x-axis, and that would be the x coordinate. And this doesn't like me right now, coordinate. And it tells you how far to move along the y-axis, that would be the y coordinate. Coordinate. All right, this is not liking me today. So as I mentioned, what we have here is what's called an ordered pair. And an ordered pair is it's a coordinate of a point, and it's always written as x comma y in brackets, so our x variable and our y variable. And what this tells us is, in this case, 5, 3. 5 is the x. It tells us that we go to 5 on the x-axis. And the second number is the y-coordinate, 3. It tells us that we are at 3 on the y-axis. So if we find where 5 on the x-axis and 3 on the y-axis meet, that's where our point is. Where do we get this point? From a t-table. So when we go ahead and collect data of x and y data, independent and dependent data, somewhere on that t-table we might say if a person, if I don't know, if it's 5 degrees outside, 3 ice cream cones got sold. And so we have this data, we can put it into an ordered pair, and then we can graph it. Ordered pairs, x comma y in brackets, must be in brackets. So what we're going to do here is we're going to plot each on the grid. So for this grid, I'm just going to assign each grid line a value of 1 so that I don't have a whole bunch of numbers all cramped in with each other. So our origin's at 0 on the x-axis. I'm just going to write in every second number. So 2, 4, 6, 8, and 10. And we got -2, -4, -6, -8, -10, so on. And go up the y-axis. We have 2, 4, 6, and 8. And likewise in the negative territory, -2, -4, -6, and -8. So we don't have to label every single number along the axes. You will know so that I went equal spacing, equal intervals here. So 2 spaces 2, 2 spaces 2, 2 spaces 2. We do have to make sure that we are labeling it properly. And if we skip labeling 3, that's fine, but 3 has to be there. All right, so to label these, we have all these ordered pairs. Remember, they are in x comma y format. So for A, 3 on the x-axis, 5 on the y-axis. So on the x-axis, I will go over to 3, and I will go up to 5, and I can plot point A. Point B is at -3 on the x-axis, so I go across to -3, and I go up to 5, and there's where my B is located. In C, -5, so I go to -5 on the x-axis and up to 3 on the y-axis, and I have C. So at this point, pause the video and try to plot the rest of these on your own, and then unpause yourself, and through the miracles of technology, I will finish the rest of these off, and you can compare your answers to mine. So pause now and try this on your own. And I'm assuming you're all back, so I'll continue doing these. So D, 3 on the x-axis, -5 on the y-axis. Your D should be here. E is -4 and 0. So we go -4 on the x-axis, but we stay at 0 on the y-axis. F is at 0 on the x-axis, so we don't move left or right, but up to 5 on the y-axis. G is at 1 on the x-axis, 0 on the y-axis, so there's my G. H is at 0 on the x-axis, -3 on the y-axis. And I is at 2 on the x-axis and all the way up to 7. And so there we go. Hopefully you got some good results there. All right, in this case, we're given a bunch of points and we have to match them with these coordinates. So for A, I'm looking at 1, 2, 3, 4, 5, 6, 7 on the x-axis and 0 on the y-axis. So that, of course, would be the D there. For G, 1, 2, 3 on the x-axis, 1 on the y-axis. That's located at 3, 1. So there's G. G is G. D, let's do D here. 0 on the x-axis. 1, 2, 3, down to -4. So that's 0, -4. And we can see here that that's this one. So once again, pause yourself. Try to do this on your own, so you're not just copying down my work, but you are making sure you know how to do it. And then unpause yourself and see if you're right. So C is at -2, -1. H is at 2, -2. B here, -3 on the x-axis, 4 on the y-axis. E is at 2 on the x-axis and up to 5 on the y-axis. So we're always doing going along the x-axis first and then up or down the y-axis. And H, I'm going to go along the x-axis to -5, and I'm going to go up to 1, and we get F. Write the coordinates of each point. So point A is located at 1, 2, 3, -4 on the x-axis. So that's over to -4. And down to -2 on the y-axis. So you should have brackets -4, comma -2, closed bracket. B is located at 1, 2, 3, 4, 5 on the, 0 on the x-axis. It's not left or right. And 5 on the y-axis. It's up here at 5. C, 2, 4. If we go across to 5 on the x-axis and up to 3 on the y-axis, we get C. D would be if we go left 1 on the x-axis, so we go to -1 and up to 3. And you'll notice that C and D are both at the same level. They are both 3 on the y-axis. E would be if we go 2 on the x-axis and we don't go up or down, so it's just 0 on the y-axis. And F is one of our special points. It's located at 0, 0, the origin. So you should kind of memorize that the origin here is 0, 0. All right, complete the table of values and plot the points. So we have some independent data here, -2, -1, 0, 1, and 2. And we want to find the y. Now the y is x minus 1. So what we're going to do to figure out the y is we're going to sub in for the x here, our x value. So in this case, I'll sub in -2. -2 minus 1 is -3. And whenever you sub in, make sure you're using brackets. So I'm going to do it again. I'm going to sub in -1. And so y is equal to -1 minus 1, which is -2. Doing it again, we can sub in 0 this time. Here's my 0. And we get y is equal to 0 minus 1, which is -1. Subbing in 1 this time. 1 minus 1 is 0. And if I sub in 2, y is 2 minus 1, or 1. So we now have a t-table with some information on it. We want to know, is there a relationship here? Let's graph it and see if we can see if there's a relationship. Now, once again, so you can hopefully you can see the black x and y axis, my x-axis and my y-axis. And just going to label. Remember, we label the lines. We don't label in between the lines. So this line here is 5. 1, 2, 3, 4. -1, -2, -3, -4. -1, -2, -3, -4. All right, and we can plot these points. So this point here is located at -2, -3. So I can go to -2 on the x-axis, -3 on the y-axis, and I can put a point. This second relationship is at -1, -2. So -1 on the x-axis, -2 on the y-axis, and I put a point. My third point is at 0 on the x-axis, -1 on the y-axis. 1 on the x-axis, 0 on the y-axis. And our last point, 2 on the x-axis, 1 on the y-axis. And we get a line. When you first looked at this data here, was there a relationship? Maybe you were able to spot it, maybe you weren't able to spot it. What type of relationship was it? Was it exponential growth? Was it linear? Was it, some other type of relationship? And we can see now that we graph it, we can see that it was actually a linear relationship. Linear meaning it forms a straight line. So once again, the benefit of a graph is we can look at that and we can see what the relationship is very quickly. And one more here. This one's a little bit trickier. I have a negative x in the relationship. And so when we sub in the -2, you need to, well, I'm going to do it this way. Y is equal to negative. Sub in just for the x and put brackets around it. So you see that's a negative x, but just the x is -2. So I subbed it in for just the x. So we have a negative out front still. So just a little thing that we have to be careful of there. Of course, when we do these signs, a negative and a negative make a positive. So 2 plus 3 is 5. When we sub -1 in, -1 is +1. So 1 plus 3 is 4. If I also sub a 0 in here, -0 is 0. We can't have a -0. Plus 3 is 3. At this point, you probably see a pattern going on. 5, 4, 3. Shouldn't assume that it's just going to go 2, 1. In this case, it is, but you should figure them out because it doesn't always go that way. And if you just assume, you might get the question wrong. Let me just erase this and clean this up a little bit. So once again, subbing in just for the x a 1. So now we have a -1 plus 3 is 2. And if I put a 2 in here, we have -2 plus 3 brings us up to 1. So 1, 2, 3 on the x-axis. -1, -2, -3 on the other side, and of course 0 in the middle. On the y-axis, we have 1, 2, 3, 4, and 5. and -1, -2, -3 type of thing. And we can plot these points, we can make them into ordered pairs, -2 and 5. -2 and 5. So we go to -2 on the x-axis and up to 5 on the y-axis. -1 and 4. So -1 on the x-axis up to 4. 0 and 3. 1 and 2. And 2 and 1. And I think these last two are good examples of why we have to make sure that we're always doing x comma y. If we're mixing them up, we'd end up plotting these in the wrong spot. Once again, we can see that there is a relationship because it forms a line, and in fact this is a linear relationship. So there we go, ladies and gentlemen. I will post the appropriate text pages that you need. I believe there's also a handout that you have to do. So I'll post that in Edsby as well. And make sure you understand this. Make sure you can plot these. As I said, moving forward, we're going to be doing a lot of graphing, and you have to be able to accurately and consistently graph these points and be able to do these lines and these graphs. I try to combine two words there. If not, you're going to have some difficulty moving forward. So make sure that you are proficient in graphing these, and if there's any issues, please reach out to me. All right, have a great day, everyone.